particle accelerator basics. So that's the content. You've got the slides you can read through yourself later on. That's what we would have used in school, where you've got this glass flask here. You might have seen it before in National 5. What's going on inside there is you've got a hot wire, a hot cathode filament, which produces electrons. The electrons are then accelerated by high voltage, which is this anode here, which has a high up to 5,000 volts. The electrons are then accelerated across and then fluoresce on the fluorescent paint on the screen. So that's how you get the beam. It's how the old cathode ray televisions used to work. The thing you need is to be able to use this equation here. The acceleration is caused by the energy that the electrons are given. So here there's a voltage, and the electrons that have a charge 1.6 times 10 to the minus 9 coulombs are given energy, kinetic energy. It's that kinetic energy which gives them a speed, which allows them to move across through there. And that's why it's called a particle accelerator, because it's accelerating it. So the definition of electrical potential is the amount of work per unit of charge in an electric field, because there is an electric field between there and there. I haven't shown the electric field lines, but it's an electric field that makes an electron move. So we give it the energy where the energy is either W equals QV, and that's the way that the SQA write it on the formula sheet, but the definition of potential is that it's the amount of energy per unit charge, or the number of joules per coulomb. But that's the way you'll see it, W equals QV. So now you've got to try this yourself there. You've got the equation. Can you work out how much kinetic energy an electron would gain accelerated by 1.5 kilovolts? Remember, you can't use the kinetic energy equation because you don't know the mass and the speed, but what you do know is that electrical potential energy is converted into kinetic. So you work out W equals QV, that'll give you the kinetic energy, and then in the next part you can then use half mv squared to get the final speed. Try it yourself on paper and then go back to the slides and see if you can check your answer.